Hello, and welcome to the AI Research Roundup. I am Alex, your host. Today is May 13th, 2025. We're looking at Flow-GRPO, Training Flow Matching Models via Online RL, a trending paper from Hugging Face, published just 5 days ago. This paper introduces Flow-GRPO, the first method to integrate online reinforcement learning, where AI learns by doing with flow matching models, which generate images but can find complex scenes tricky. It employs two core strategies: converting deterministic ordinary differential equations, or ODEs, into stochastic differential equations, or SDEs, to add randomness crucial for exploration, and a denoising reduction strategy to efficiently speed up generating samples for training. Alright, so looking at the results, we can see how effective these strategies are. One plot illustrates performance on Generative, which is a benchmark specifically for complex image compositions. Here, the Flow-GRPO method boosts the SD 3.5 medium model's score substantially, up to 0.95, as training progresses. Crucially, other plots show that standard image quality remains high, and scores from model-based reward systems like PickScore, which predict human preferences, also increase. This indicates improved capabilities without that tricky problem of reward hacking, where the AI just learns to gain the score. So, how does Flow-GRPO achieve these improvements? Well, this figure gives us a great overview. On the left, it shows the image generation as a Markov decision process, which is essentially a framework where the AI makes a sequence of decisions to refine an image step by step. This process uses the ordinary differential equation to stochastic differential equation conversion for exploration. And crucially, it employs denoising reduction, using fewer steps to quickly create training samples. These samples then inform the group relative policy optimization on the right, which is the learning algorithm that updates the model. Building on that, this figure visually demonstrates these gains. It is a qualitative comparison on the Generative benchmark, showing side-by-side results for various prompts. We can see different models attempting tasks like counting objects, getting colors right, and crucial for complex scenes: attribute binding. Attribute binding is the AI's skill in correctly linking descriptions, like red, to the right object, say an orange, and not to the broccoli next to it. The bottom row representing the Flow-GRPO enhanced model clearly shows superior handling of these complex instructions compared to other models shown. Okay, so this table provides the hard numbers backing up those visual improvements we just saw in the Generative benchmark. It compares different types of generative models, like diffusion models, which gradually refine an image from pure noise, autoregressive models that construct images sequentially, a bit like writing a story word by word, and of course the flow matching models we are focusing on. Across various categories, including that tricky attribute binding, the SD 3.5 medium model enhanced with Flow-GRPO consistently scores highest, often by a large margin. For instance, its overall score jumps to 0.95, which is a substantial leap. So to wrap things up, Flow-GRPO clearly enhances flow matching models for complex image generation. The key is its smart use of online reinforcement learning, enabled by the ordinary differential equation to stochastic differential equation conversion for exploration, and denoising reduction for faster training. This boosts performance significantly, improving attribute binding and text rendering while maintaining image diversity, often using tools like a KL constraint. A KL constraint essentially keeps the model from becoming too repetitive. That is all for this AI Research Roundup. Thanks for tuning in.